Hey everybody, how you doing? I got a double lesson for you today. Ultimate excitement. Um, I want to show you how to be able to find sine and cosine, but if I'm going to show you how to be able to find sine and cosine, I need to make a quick video on how to build unit circle. Now keep in mind, I'm not talking about the whys on this lesson, I'm just talking about the hows. How to build unit circle. Well, the first step of building unit circle, drawing a circle, a good, nice, round circle, as round as you can make it, and putting an X and a Y axis in there. And this point here in the middle of the circle is 0, 0. And I go around the circle total of 4, 5 times, 6 times. Anyway, first I go around the circle in degrees. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Then I go around the circle again, but I mark up every 30 degrees. So I have 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, 360 degrees. So one time around, going every 30, then go around one more time, this time marking up every 45s, every 45 degree angle. So 0, 45, 90 degrees, 135 degrees, 180 degrees, 225 degrees, 270 degrees, 315 degrees, and 330 degrees. That was going around in degrees. Now I'm going to go around in radians in a different color. This is a distance of 0. All the way around the circle would be 2 pi. If you go halfway around, that's pi. Up top, pi over 2. Down below, 3 pi over 2. Kind of the special cases. Now, I'm going to go around, and I'm going to go around to kind of for the 30 degrees. That's like going pi over 6. Because pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, which is pi. Once again, pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, pi over 6, pi over 2, 4 pi over 6, 2 pi over 3, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6, which reduces to 3 pi over 2, 10 pi over 6, which reduces to 5 pi over 3, and 11 pi over 6. Then, I needed something to mark the 45s. If you think about it, 45 is a quarter of the way to pi. So this is pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4, or pi. 5 pi over 4. 6 pi over 4, which reduces to 3 pi over 2. 7 pi over 4. And then 8 pi over 4, which reduces down to 2 pi. Alright, next thing we need is we need the coordinates for all of these measurements around this circle. Now, quickly, friendly reminder, in a 30, 60, 90 triangle, this is x, this is 2x, this is x root 3. And if we were to build a triangle using this 30 degree mark here, that right triangle would look like this. And what's that radius of unit circle? 1. And in this triangle, that's the hypotenuse. So, if I go back to here, if I have a hypotenuse of 1, that means that this edge here would have to be 1/2 divided by 2. And then you take that x and you multiply it by root 3, and if you multiplied 1/2 by root 3, you'd get root 3 over 2. So this triangle is the same thing as this triangle right here. This distance was root 3 over 2. This distance was 1/2. That means that this coordinate is root 3 over 2, comma 1/2. Now, this triangle could work for this angle, this angle, this angle, or this angle. So all four of these angles have the same numbers, just positive, negative things. This is the second quadrant, so it would be negative root 3 over 2. At 210, it's still root 3 over 2 and 1/2, but because it's the third quadrant, both of them are negative. Way over here, fourth quadrant, it's still root 3 over 2 and 1/2, but because it's the fourth quadrant, the y-coordinate would be negative. Other than that, these coordinates are exactly the same. Interesting. And if you know the 30-degree angle, you know the 60-degree angle, it would just be it'd be flipped around. So instead of being root 3 over 2 comma 1/2, flipped around. So this coordinate is 1/2 comma root 3 over 2, which means if this angle is the same, that means that the 120 would also be the same. 1/2 root 3 over 2, but because it's second quadrant, the x-coordinate would be negative. Down here, 1/2 root 3 over 2, but it's third quadrant, so they're both negative. And then same thing with the fourth quadrant. Oops, 1/2 root 3 over 2, but because it's the fourth quadrant, the y-coordinate's negative. How do you know these are all the same? Reference angle. At 30 degrees, 150 degrees, 210 degrees, 330 degrees, they all have the same reference angle, so their numbers are the same. Just the positives and negatives change. What's the reference angle of 120 degrees? It's 60 degrees. What's the reference angle of 240 degrees? It's 60 degrees. What's the reference angle of 300 degrees? It's 60 degrees. Which means all of these angles that have a reference angle of 60 degrees have the exact same xy coordinate, just different positives and negatives. All right, 45 degrees. For that, you think about the 45, 45, 90 triangle with a hypotenuse of 1. We learned this to be x, x, and x root 2. So if the hypotenuse is equal to 1, that means x would have to be equal to 1 divided by root 2. But you don't answer with the root on the denominator. That's silly. So you multiply it by root 2 over root 2, and you ultimately get root 2 over 2. That means this side is root 2 over 2, and this side is root 2 over 2. And if we were to put this triangle right here on 0, 0, this coordinate would be root 2 over 2 and root 2 over 2. Now, what angle in the second quadrant has a reference angle of 45 degrees? Well, that's 135 degrees. So this would also be root 2 over 2 and root 2 over 2, except the x-coordinate's negative. In the third quadrant, you're looking at 225 degrees, so negative root 2 over 2 and negative root 2 over 2. And then in the fourth quadrant, 315 degrees has a reference angle of 45 degrees. So I'd go root 2 over 2, negative root 2 over 2. Whoo! Two more things to add. These are all of these, these angles that have the same reference angle, but there are some special cases. What's the coordinate at 90 degrees? Think radius of 1. At 90 degrees, the coordinate would be 0, 1. At 180 degrees, a radius of 1, if you go 1 to the left, you're at negative 1, 0. Down below, you're at 0, negative 1, and over here at 0, your 1, 0. And that, my friends, my students, is how you find unit circle in 10 minutes. So, that's it. Have yourselves a beautiful day, and I'll talk to you soon. I'm actually going to make another video right now, and that video is, how do you use unit circle? You use it to find sine and cosine. That's how. Talk to you soon. Bye-bye.